In order to work out the area underneath this curve, we're going to integrate between the limits of x equals 0 up to x equals 4, and our equation for y is given in the question. So we're going to use a substitution in order to integrate this. We're going to let u equals 4 plus 3x. And I'm doing that because that's going to make my integral simpler. I'm going to have just 9 over root u. But we want to replace dx with something to do with du. So let's get rid of that dx. In order to do that, we're going to work out du by dx, which is 3. So that tells us that dx is equal to a third du. So we can replace dx with a third du. And I'm actually going to change the limits. You could integrate it and then go back to x, but I'm going to do everything in terms of u and change the limits. So with the lower limit, what we really mean here is x equals 0 and x equals 4. So when x equals 0, u is equal to 4, and when x equals 4, u is equal to 16. So I know that I can change these limits to u equals 4 up to u equals 16. So now everything's in terms of u, and we can work this out. So I'm going to do 9 times by a third. A third of 9 is 3. And I'm going to write 1 over the square root of u as u to the power minus a half. So now we can integrate. We can increase the power by 1 and then divide by the new power. So if we increase the power by 1, we've got u to the power of a half, and then 3 divided by a half is 6. And then all we need to do is sub in the limits. So if we sub in the top limit, we're going to have 6 times by 16 to the power of a half, and then we need to subtract what we get when we sub in the lower limit. Well, 16 to the power of a half is the square root of 16, which is 4. So we've got 6 times 4, 24, and minus the square root of 4 times 6 is 12. So we're going to have 12 as our answer.